Hello viewer. So today I'm disassembling, scraping, pulling apart, whatever you prefer, a old MacBook Pro or an older MacBook Pro battery. So I've never done one of these before. I've got to say, in first glance it looks a little bit flimsy, but I guess that's to keep it as slim and thin as possible. I see interesting, they say, warning, do not remove the battery. Well, clearly someone did. And I know who. It's actually a colleague, a friend of mine at work, who's replaced his. So, right, let's see what's inside. What else is going to come off? So I'm guessing under here is actually, well, as soon as we get this sticker off, what we'll see initially is the top end of some batteries. There's no end game here to repack this or anything. This is just a pure disassembly. There we go. Here we go. So, like I've said in some of the other battery videos, is you know, there's a really good chance that some of these cells are going to be nice and, you know, still in perfectly functional condition. And when they do these packs like this, it's quite nice because, yeah, you can just reutilize them in so many different little projects. So, try not to short or cause too much damage here. Okay, I've already cut the cable. Doesn't matter. So I'm going to say that this part will have the electronics. Yep. Okay, let's try not to put too much pressure on the battery. Don't want to actually bend the battery. Yeah, the battery does have seam lines here. What I noticed when I was looking at it initially. I've glued the bloody things to them. There we go. Not ideal, but I don't think it will cause any permanent level damage. Right. Nothing like a bit of violence to begin a teardown. Okay. Let's diffuse the bomb. We'll click black wire first. It doesn't actually matter, I'm just being silly. I just figure if I separate them then. Okay, so that's a sensor. So that's the temperature sensor right there. So what that does is monitor the temperature of the battery, and if it gets too hot, it will actually shut the system down to prevent any permanent damage to equipment, property, etc. if the battery ends up going a little bit thermal. Let's keep going. what I don't want to do is actually wreck what I don't want to do is wreck the seal. He says as he cuts the seal. So that was a bit unfortunate. Oh, there's that lithium ion smell. So I'd say I've probably invalidated the warranty by about now. What do you reckon? Okay, so let's cut that one. So yeah, that one's probably no longer useful. Do they have, okay, interestingly they don't seem to have sensors on each battery. I was just wondering, being an Apple product, whether they might go to that level of having the protection at each point. Oh, that one come off. And that's so all the circuitry is just in that little hub actually. That's nice and tight. It's quite a nice design actually. Build quality seems really nice. I haven't done a lot of Apple products, so I mean, I know they're expensive, but expensive doesn't always mean well built. You know, especially when you do hear a fair few complaints. So that's the charge controller and monitor and supply. The one thing I was wondering is these are relatively thin connectors and wires for the power, though I would say they would be certainly well and truly doubled up. Maybe 3 for positive, 3 for negative, and the 2 cents wires. That would seem to be a relatively logical way of doing it. So, oh, that's rubber. Okay. Wonder if that's just some sort of dampening to cut down vibration somewhere along the line. And they've just used the battery pack to do it. So there we go. That is 6 cells, one of which I probably buggered ahead of time. Potentially 1 or even all 6 are already no good. Obviously the way of testing that is to start tearing them down and then testing them on a cell by cell basis. So what they've done is they've crossed, I'll see if I can show it. So if we look here, so you can see your 2 terminals. So that's one battery, that's the other battery, and then they wire them in parallel so that each negative is co-joined and then the positive is co-joined. So you can see that in the, let's see if we can pull that apart. There we go. Okay, so you can see that those 2 are joined and then those 2 are joined. So clearly that's the positive and that's the negatives. See that, because the red wire was hooked to that one. So, you know, I'm definitely not going to be using these in a Windows, a Apple device. So actually, I might use some scissors. These are my favourite scissors. I like them so much that when I broke the handle, I 3D printed a new handle. As a good way of extending the life. But they're good. They good sharp scissors. So I'm going off on a bit of a tangent here. I tend to do that. They're actually really nice sharp scissors. Good for I use them to cut material. Use them to cut plastics. Use them to cut metal. And they just keep on trucking. The only thing that let them down is the handle. As you can see, I've had to reinforce that a few times. I need to actually print a 3D version of that. So when I busted the handle, I just designed and printed out a 3D version. Didn't refine it too much, just enough to be comfortable and strong. It's been good. Right, so I'm not going to separate these. Basically because I'm going to guess that it might not be too easy. Keep that sense again. So what I will do though is, because I actually cut through one on the third pack or the middle pack, what I'll do is I'll try and separate that one and see how I go. So there you got the same thing here, except these are actually been invert. 6B, no, that's the same. Okay, so again, that's positive. And okay. So these are negatives, these are the positives. So right now, that is one cell, that is one cell. But in the context of the battery pack, the way it was being used is they were treating this as one cell. So they were wired in parallel. No individual sensing on each cell. They're just wired in parallel and then treated as one cell. So this is the one that I wrecked and cut through the cover. So let's just pull, do the same thing. Yeah, separate that out. What I'm going to do, let's fold those. So this is the cell that I cut through the binding. So I'm just going to this is just because the fumes, the smell. I mean, I haven't actually corrupted the cell. I mean, that's not fixed, you know, don't get me wrong. I'm not saying that that's how you fix it. Okay. Let's see if I can get these apart. just going a bit gentle here because I don't want to distort. Oh, that's actually separating quite well, I think. Okay, so there was much less stiction between the two batteries, the two cells, than there was between the cells and the case. So that's buggered. I'm not going to try and use that. That's going to be disposed of. I will not be putting it into landfill. There's a battery deposit bin that I can put this into. I'll cut the terminals down a bit more, for my peace of mind, and also to prevent shorts. So I'll dispose of that, and that leaves me with five cells which I'll test, and if I'm lucky, I'll have you know, 1, 2, 3, 4, or even maybe all 5 good cells, because you know, you never know if the problem's in the controller, or maybe the problem was this battery. How lucky would that be? But the odds are that there'd be 2 down, because they run in parallel, but you know, until I test it, I don't know. So that's it. That's what the insides of a slightly older MacBook Pro battery looks like. Actually, it's a design I like. I'm quite impressed with it. There's minimal plastic, which is good. Unfortunately, that does have to go into landfill. There's not much I can do about this at the moment. This can just go with the circuit boards for disposal, for recycling, and that's about it. So thank you for watching. I've rambled on a little bit, I know. Please excuse that. It's the nature of my videos. So have a good one.